It always starts quietly, a faint point of light, barely brighter than the background stars. No warning, no drama, just a whisper in the data. On a cold night, inside a room filled with screens and soft humming machines, astronomers noticed something new drifting across the sky. Another object, another visitor, another line of numbers on a chart. They named it 3I/Atlas. At first, it sounded ordinary, a designation, a catalogue entry, one more object slipping along the ecliptic, following a path carved by gravity and time. From far beyond our solar system, another interstellar traveller. We've seen them before, or at least we think we have. Rocks, ice, dust, leftovers from other stars passing through, never stopping, never caring that we're here. So when the discovery was announced, there was no panic, no headlines screaming danger, just calm voices explaining what we already believed. It's natural, it's harmless, it's just passing through. But even in that first light, something didn't feel right. When astronomers plotted its movement, they expected a familiar curve. A gentle arc shaped by the sun's pull, predictable, clean, boring. Instead, the motion hesitated. Not enough to alarm anyone, not enough to trigger headlines. Just enough to make a few people lean closer to their screens. The numbers were correct, the instruments were working. But the object's path felt stiff, almost restrained, like it wasn't fully surrendering to gravity. Then came the reflectivity. Every object reflects light differently. Ice scatters, rock absorbs, dust softens the glow. 3I/Atlas didn't do any of that properly. Its surface brightness shifted in ways that didn't match rotation models, too smooth in some moments, too sharp in others, as if different parts of it were responding. Astronomers checked their instruments again. Calibration errors are common. Cosmic rays hit sensors, data gets messy. But the anomaly stayed. Night after night, the same strange glow returned. The same subtle imbalance in the light curve. It wasn't bright, it wasn't dramatic, it was precise. And precision in deep space always raises questions. At first, the discussion stayed technical. Quiet emails, late-night messages between observatories. Has anyone else seen this? Are your numbers lining up? Can you double-check the reflectivity band? Across continents, the answers came back the same. Yes, yes, and yes. The object wasn't misbehaving loudly. It wasn't breaking laws. It was bending expectations. Just enough. As days passed, the sun grew closer in its frame. Perihelion was still ahead, but the solar influence was rising. Heat should have caused chaos. Outgassing. Jets of vapor. A messy, uneven glow. But 3I/Atlas stayed calm, too calm. Its brightness didn't spike the way models predicted. It adjusted, smoothed itself out, almost like it was compensating. That's when the silence changed. Not silence in space, silence in the room. Conversations slowed. Jokes stopped landing, because no one wanted to say the word forming in their minds. Artificial. Not because it looked like a machine, not because it transmitted a message, but because it behaved like something designed to endure, designed to pass close to a star and stay stable, designed to be seen, but not obvious. A few researchers ran alternative simulations. Nothing official, nothing publishable. They treated the object not as a rock, but as a structure. The results were unsettling. The data fit better. Not perfectly, but better than nature alone. Still, no one panicked. Science doesn't jump to conclusions. It waits. It watches. And so they watched. 3I/Atlas continued its silent glide along the ecliptic. Its light steady, its motion controlled. No tail. No dramatic flair. Just presence. And presence sometimes is more disturbing than action. The discovery announcement stayed clean and calm, carefully worded. No mention of anomalies. Because what do you say when you don't yet understand what you're seeing? What do you tell the world when the first light already feels like a question drifting toward us from another star? As the days went on, the object grew brighter, clearer, harder to ignore, and with every new observation, one thought quietly followed the data. If this is just a visitor, why does it feel like it knows exactly where it's going? And maybe more importantly, why does it feel like it knows we're watching? The sky had given us something new. Not a threat, not a message, just a presence. And presence is where stories begin. Because once something is seen, it can't be unseen. And the first light of 3I/Atlas had already done its damage. It had planted doubt. And doubt, once born, only grows. Everyone thought they knew what would happen next. They always do, because space, most of the time, follows rules. Cold rules, old rules. As 3I/Atlas moved closer to the sun, astronomers prepared for the obvious. Perihelion was coming, the point where heat bites hardest, where ice cracks, where objects reveal their true nature. Comets flare. Asteroids warm. Light rises. Chaos begins. That's the script we've trusted for decades. So the models were ready, lines drawn, graphs smoothed, predictions locked in. Brightness would climb steadily. Heat would increase in a clean curve. The light curve would swell like a heartbeat under stress. But when the data arrived, it didn't follow the script. At first, it was subtle. A small deviation, barely worth mentioning. The light curve rose, then slowed. Not stopped, not spiked. It adjusted, as if something was pressing gently against the sun's influence. Astronomers stared at the numbers, waiting for the correction to appear. It didn't. They checked again the next night, and the next. The anomaly stayed. The brightness increase was uneven, not chaotic, not random. Controlled, like someone easing off a pedal. Heat readings followed the same strange logic. Solar energy increased. Distance decreased. But the thermal response didn't match. Too cool in some regions. Too stable in others. Not cooling fast enough to be inert. Not heating fast enough to be natural. Just balanced. And balance near a star is rare. Perihelion is where objects break, where flaws show, where nature loses control. But 3I/Atlas wasn't losing control. It was holding it. Some researchers thought it was rotation, a slow spin exposing reflective surfaces. Others suggested an unusual composition, exotic ice, unknown alloys of dust and metal. Every theory tried to pull it back into the comfort of nature, but none fully explained the bend in the light curve. Because the curve didn't just wobble, it leaned. A smooth, deliberate lean, away from expectation, as if the object was responding, not reacting. This wasn't a sudden flare or an outburst. There was no violent jet of gas, no tail exploding into view, just quiet resistance. One astronomer described it in a private message. It's like it's aware of the sun, but not afraid of it. That sentence was never meant for the public, but it captured the unease perfectly. Because fear is messy. What they were seeing was calm. The closer 3I/Atlas moved, the more the models began to fail. Old equations started leaving gaps. Assumptions fell apart. Gravity still worked. Physics still held. But something else was shaping the path. A force too gentle to detect directly, too consistent to ignore, and too intentional to feel accidental. The idea crept in slowly. What if the object wasn't just passing the sun? What if it was managing the encounter? Adjusting orientation, redistributing heat, controlling reflectivity, not in a dramatic way, in a quiet way. The kind of way that doesn't scream for attention, but rewards careful watching. Across the world, observatories compared notes, different instruments, different skies. Same result. The light curve wasn't broken. It was behaving, and behavior implies choice. That's when discomfort replaced curiosity, because science is built on causes, not intentions. You can model ice. You can model rock. You can even model chaos. But you can't easily model purpose. As perihelion drew closer, tension filled the data rooms. Eyes stayed on screens longer. Coffee went cold. No one wanted to be the first to say it out loud, but everyone felt it. This object wasn't surrendering to the sun. It wasn't fighting either. It was negotiating, minute by minute, degree by degree. The curve kept bending, not away from danger, but away from expectation. And expectation is the foundation of trust. The public still knew nothing. Press releases stayed neutral. Language stayed safe. Unusual behavior. Interesting data. Further study required, but behind closed doors. The question changed. Not what is it made of, but why does it act this way? Perihelion arrived without drama. No explosion. No brilliant flare. Just a smooth pass, like it had rehearsed it. And as the object began to move away from the sun, something chilling became clear. The light curve didn't snap back. It didn't overcorrect. It eased, exactly as predicted. But not by the old models, by the new ones. The ones that assumed adjustment. The ones that treated the anomaly as a feature, not a flaw. That's when the realization settled in. This wasn't a mistake in the data. This was the data. Something out there had passed a star and done it cleanly. No panic, no waste, just control. And control in deep space is rare. As 3I/Atlas continued its journey, one quiet thought lingered in every room where the data was studied. If this object can manage a star, what else can it manage? And if it's managing its path, who or what set it on that path in the first place? The sun faded behind it. The anomaly remained, and the light curve was only just beginning to speak. At first, they told themselves it would pass. Most anomalies do. A bad night of seeing, a faulty sensor, a statistical hiccup that disappears once enough data piles up. That's how science survives, by trusting that noise eventually cancels itself out. But with 3I/Atlas, the noise never faded. Night after night, telescopes stayed locked on the same faint shape, drifting through the dark. Different countries, different instruments, different skies. Same result. The light curve refused to behave. Normally, brightness changes smooth themselves over time. Tiny errors blur together. Sharp edges soften. Randomness becomes random. But this curve didn't smooth out. It sharpened. Each observation added definition, not confusion. The dips were always in the same place. The peaks arrived on time. Too clean, too consistent. It was like listening to static far and realizing the static had rhythm. At first, the pattern was almost invisible. You had to stack the data, overlie the nights. Then it appeared. A repeating structure. Not perfect, but close enough to make people uneasy. The object brightened, paused, dimmed, paused again. The timing wasn't exact down to the millisecond. But it didn't need to be. It was precise in the way living systems are precise. Flexible, yet stable. Someone joked that it looked like a heartbeat. The joke didn't land, because heartbeats belong to things that are alive. Others argued rotation. A spinning object with uneven surfaces could explain the cycle. But when they modeled it, the math fell apart. The rotation speed would have to change slightly, every cycle in exactly the same way. That doesn't happen naturally. Rotation slows. Rotation wobbles. Rotation degrades. This didn't. The light curve held its shape like it was being maintained. That's when the argument started. Quiet at first, then sharper. One camp said, instrumentation error, hidden bias, unknown calibration drift. The other camp said the words no one wanted to hear. This looks intentional. Emails grew longer. Meetings grew tense. Every explanation was tested, and tested again. Cosmic dust clouds? No. Magnetic interactions? Doesn't fit. Outgassing jets? They'd be messy. This was not messy. The curve wasn't chaotic. It was composed, almost deliberate. One researcher described it as too polite, as if the object was knocking, not breaking down the door. Across the globe, the same pattern emerged. A dip, a rise, a pause, again, and again. It didn't drift. It didn't decay. It repeated. And repetition is dangerous, because repetition implies memory. You can excuse one strange night. You can excuse two. But when the third, fourth, fifth night lines up, you stop asking if something is wrong. You start asking why. The phrase broken light curve began circulating quietly. Not broken as in damaged, broken as in refusing to obey. Like a rule that suddenly stopped applying. Some scientists leaned back in their chairs and stared at the ceiling. Others leaned forward, closer to the screen, like proximity might reveal a secret. No one spoke for a while. Because if this wasn't error, if this wasn't noise, then the only remaining option was design. Not necessarily alien, not necessarily a machine, just purposeful. And purpose makes people uncomfortable, because it pulls science into the same room as philosophy. Late one night, a young analyst ran a simple test. He stripped away all assumptions, no labels, no expectations, just time and brightness. The result was chilling. The signal aligned with itself across weeks. That shouldn't happen. Random systems drift. Natural systems degrade. This one, remembered. Word spread faster than anyone intended. Not to the public, not to the media. But within the community, people started asking different questions. Not, what is it made of? But, What is it doing? And once that question exists, it never goes away. Arguments grew louder. Some accused others of seeing patterns where none existed. Pareidolia of the data. You want this to be strange, they said, so you're forcing it. Others fired back. We didn't choose the pattern. The pattern chose us. Careers were quietly on the line. No one wanted to be associated with a mistake this big. Or worse, a truth this uncomfortable. Meanwhile, 3IATLAS kept drifting, unbothered, unchanging, its light curve ticking away like a clock no one had built. That's when someone noticed something even worse. The pauses. Between each rise and fall, there was a pause. Not gradual, not smooth. A moment of stillness, as if the object was waiting. Waiting for what? No one knew. But waiting implies awareness, and awareness implies perception, and perception implies something more. The room went quiet again, because broken things behave wildly. This wasn't wild. This was restrained, controlled, measured. The kind of control that doesn't come from chaos, but from intention. By now, some researchers stopped taking notes. They just watched. Because you don't annotate a question like this. You sit with it. You feel it. And the feeling was heavy. As the nights passed, the broken light curve refused to heal. It stayed broken. Or maybe it was never broken at all. Maybe it was finally being seen correctly. Outside, the world slept. Cars passed. Lights flickered. People lived normal lives under a normal sky, unaware that something out there, something silent, was repeating itself with perfect patience, as if it had all the time in the universe. And maybe it did. By the end of the week, one unspoken truth settled across the community. If this is an error, it's the most disciplined error ever recorded. And if it's not, then we're no longer just observing an object, we're observing behavior. And behavior always leads to one final question. Is this just physics playing tricks on us? Or are we watching intention move through the dark? The light curve kept repeating. The answer did not come. And somewhere between the stars, something kept pulsing. Quietly, patiently, waiting. It began as a whisper, so faint that most people missed it at first, so soft it hid inside the noise. A tiny rise, a tiny fall, buried deep in the signal. At one observatory, a technician flagged it as interference. At another, it was ignored completely, because space is full of flickers, cosmic rays, background stars, electronic ghosts. Nothing unusual about a pulse. Until it came back. Same timing, same shape. Then it came again. That's when someone noticed something strange. The pulse wasn't local. It wasn't tied to one telescope, or one country, or one night. It was everywhere. Chile saw it first, then Hawaii, then Spain, then Australia. Different hemispheres, different instruments. Same pulse. At first, the times didn't line up perfectly. A few seconds off here, a few milliseconds there. That was comforting, because randomness breathes. It drifts, but as more data arrived, the drift vanished. The clocks began to agree. Someone adjusted for light travel time. Another corrected for Earth's rotation, and suddenly the pulses aligned to the second. The room went quiet, not because they were afraid, Gad, but because everyone understood what that meant. Synchronization is hard. Synchronization across continents, across moving planets, across spinning telescopes, that's almost impossible by accident. Yet, there it was, a steady rhythm, not fast, not urgent, just consistent. Tick, pause, tick, like a lighthouse blinking in deep space. Some argued it was coincidence, a shared bias in the data pipeline. So they stripped the signal down further. Raw photons, no processing, no smoothing. The pulse survived. It didn't care what software touched it. It didn't care who looked at it. It stayed. That's when the questions changed again. Because this wasn't just a light curve anymore. This was timing, and timing is everything. Natural systems fluctuate. They wobble. They drift under pressure. This didn't. The pulse kept its pace as 3IATLAS moved closer, then farther, then changed orientation. Distance changed. Angle changed. Time did not. One astronomer whispered something no one forgot. It's keeping time better than we are. That wasn't exaggeration. Atomic clocks on Earth have limits. They require maintenance. Corrections. This pulse needed none. It arrived when it should. Left when it should. Every time. And worse. It wasn't speeding up near the sun. It wasn't slowing down in the cold. It didn't care where it was. That meant the timing wasn't caused by environment. It was internal. The idea hit like a cold wave. Internal timing means reference. A clock, and clocks are built for reasons. Some tried to explain it away. Rotational resonance, surface oscillations, magnetic interactions with solar wind. But every explanation broke somewhere. The pulse didn't smear, didn't weaken, didn't blur. It stayed sharp, like a decision repeated endlessly. As the nights passed, scientists stopped calling it a pulse. They started calling it a signal, because pulse implies accident, signal implies intent. Still, no one said message. Not yet. Messages carry meaning. Meaning demands responsibility. This could still be something else, couldn't it? The timing was examined again and again. Then someone noticed something terrifying. The pulse didn't match Earth time. It matched itself. No reference to our seconds. No alignment with our clocks. Just an interval. A constant interval. As if it had brought its own measure of time. Its own rhythm. Its own standard. That realization landed hard. Because if something carries its own clock through interstellar space, it wasn't built to drift. It was built to endure. Across labs, the mood shifted. Excitement drained away. Curiosity gave way to unease. Because discovery is thrilling, but recognition is sobering. People started asking quieter questions. Who built it? When? Why send something that pulses, but never speaks? Some suggested it wasn't for us. That hurt more than the alternative, because that meant we were incidental, observers of something never meant to notice us. The pulse continued, as if mocking the debate. Tick, pause. Tick, no acceleration. No decay. Just patience. A few researchers tried something risky. They overlaid the pulse timing with known natural frequencies. Planetary rotations. Stellar oscillations. Nothing matched. Then they compared it to artificial patterns. satellite beacons, navigation signals. It didn't match those either, which made it worse, because it wasn't crude. It wasn't human. It was elegant, minimal, wise, like something designed to waste nothing. At one point, a senior astronomer closed his laptop and said softly, "This thing knows how long it's been traveling." No one argued, because the math agreed. If the pulse had been running for centuries, millennia, it would still look exactly the same. That means whoever set it in motion didn't care about decay. They planned for distance. They planned for time. And suddenly, everyone felt small. Because humanity measures history in thousands of years, the universe measures it in billions. This pulse didn't belong to our scale. As 3I/Atlas continued across the sky, the signal never wavered. It crossed hemispheres, crossed seasons, crossed expectations. It was indifferent to us, and that indifference was louder than any message. Eventually, someone asked the most dangerous question of all. What if this isn't communication? What if it's navigation? The idea spread quickly. A timing signal, a reference beacon, something meant to orient, not converse. A tool, not a greeting. That meant 3I/Atlas wasn't just an object. It was infrastructure. Something placed, not sent. The pulse ticked on. Unaware, or uncaring, that a species beneath it was quietly unraveling. Because once you accept that something unknown can keep perfect time, you have to accept what comes next. If it can measure time, it can measure space. If it can measure space, it can plan. And if it can plan, then this journey wasn't random. It never was. The sky above Earth looked the same as always. Stars still burned. Planets still moved. But something had changed. We were no longer alone with our clocks. Something else was counting. Somewhere out there, something was keeping time, and it wasn't counting for us. As the pulse crossed another night, perfect, unbroken, one question echoed in every silent room. If this signal is so precise, what happens when it stops? Heat is honest. In space, it has no reason to lie. Objects warm when they get close to a star. They cool when they drift away. Simple, predictable. Poem, trusted. That's why temperature data is usually comforting. It follows rules older than Earth itself. So when the thermal readings for 3I/Atlas came in, people expected reassurance. They didn't get it. The first reports were confusing, not alarming. A slight dip where there should have been a rise. A plateau where heat should have spiked. Someone blamed shadowing. Someone else blamed rotation. Easy fixes, until the pattern repeated. Again and again. As the object moved through sunlight, parts of it cooled. Not gradually, not smoothly. They cooled on schedule. Then, minutes later, they warmed again. Not explosively, not erratically. Measured, like someone turning a dial. One click at a time. The thermal pattern didn't match ice, didn't match rock, didn't match dust or metal. It didn't match anything in the catalogue. Most objects near perihelion show stress, fractures, jets, violent swings. This didn't. It stayed calm. Too calm. Heat flowed across its surface, then stopped, as if it hit an invisible boundary. As if the object knew how warm it wanted to be. That's when the fear crept in. Not panic. Not excitement. Fear, because temperature regulation is rare. You see it in machines, in living things, not in debris. Debris doesn't care if it cracks, doesn't care if it boils. This did. One scientist described it quietly. It's acting like it has limits. Limits imply intention. They pulled up every natural explanation they could find. Unusual albedo? Maybe. Subsurface ice vents? Possible. But vents cause chaos. This caused balance. The heat maps told a story the light curve couldn't hide. Certain regions never crossed a threshold, no matter how long they faced the sun. Others cooled faster than physics allowed, as if heat was being moved, redirected, managed. Someone overlaid the thermal pattern with the pulse data. The alignment was chilling. The temperature shifts followed the same rhythm, not perfectly, but close enough. Heat rose, pulse. Heat fell, pulse. Like breathing. That comparison was never written down, but everyone thought it. The rooms grew quieter, because once you start seeing systems instead of objects, you don't go back. Someone asked the obvious question. Could it be spinning faster than we think? They ran the numbers. To match the thermal behavior, the rotation would need to change constantly, precisely. That's not rotation. That's control. Control requires energy, and energy requires storage. And storage implies structure. The chain of logic tightened. Every explanation that avoided the word artificial created more problems than it solved. The thermal regulation wasn't perfect, and that made it worse. Because perfect control looks fake. This looked optimized, good enough, efficient, like something designed not to waste power. The object wasn't overheating, but it wasn't shielding itself completely either. It allowed some heat in, just enough. Why, no one knew. But why had officially entered the conversation. You don't ask why about rocks. As days passed, the temperature shifts became impossible to ignore. They weren't reacting to distance alone. They were responding to orientation. Angle mattered. Exposure mattered. Timing mattered. As if the object was aware of where it was and what it was facing. That realization sat heavy, because awareness doesn't have to mean intelligence, but regulation does. A junior researcher said something no one corrected. It feels like it's protecting itself. The words hung in the air. Protecting itself from what? The sun? Time? Us? No one answered. The fear wasn't loud. It didn't come with alarms or raised voices. It came as silence, as people stopped joking, stopped multitasking, started watching. Because something that regulates heat in deep space is not fragile. It's built to last, built to cross stars, built to survive environments that destroy most things. And suddenly, a terrifying possibility emerged. What if this object wasn't surviving the journey? What if it was meant to? Thermal regulation means endurance. Endurance means long timelines. Long timelines mean patience. And patience means intent. The object cooled when it should have burned, warmed when it should have frozen, always staying within a narrow range. Like a heartbeat maintaining temperature, like a system preserving itself across time. One scientist stared at the heat map and said quietly, "If this were closer, we'd call it alive." No one laughed, because distance was the only thing keeping that thought at bay. The closer 3I/ATLAS moved through our models, the less it behaved like a visitor, and the more it behaved like infrastructure, something placed long ago, still functioning, still managing itself, long after its builders were gone. That thought was never said out loud, but it settled in everyone's chest. Because if something can regulate heat without fuel, we recognize, without waste we can see, then our understanding of technology is incomplete, and incomplete understanding is dangerous. The public still heard nothing. No warnings, no briefings, just another object passing through. But behind closed doors, one truth became unavoidable. This wasn't heat reacting to space. This was heat being managed in space. And management means rules. Rules imply design. Design implies origin. And origin implies someone or something. That is, not us. As 3I/ATLAS continued its silent path, the thermal pattern stayed steady, unbothered by fear, unaware of debate, just regulating itself, patiently, endlessly, as if it had done this before, many times, across many stars. And as the sun's influence slowly faded, one quiet question replaced all others. If this object can control its own heat, what else can it control? And what happens when something that regulates itself decides to stop? The heat maps glowed softly on the screens. Measured, balanced, alive with order. And for the first time since the discovery, the fear wasn't about what we were seeing. It was about what we were beginning to understand. Because deep space is cold, unforgiving, and silent. Nothing regulates itself out there, unless it was built to. Light tells the truth, even when we wish it wouldn't. It doesn't care about theories. It doesn't care about comfort. It just reflects. As 3I/ATLAS continued its slow rotation, scientists expected something familiar. A gentle change in brightness, a smooth wave caused by uneven terrain. That's what rotating objects do. They reveal themselves gradually, honestly. But this wasn't gradual. The reflectivity changed in bands, sharp bands, clean, defined, repeating, like stripes sliding across the surface as it turned, bright. Dark, bright again, not blended, not eroded, separated. Someone zoomed in on the data and frowned. That edge shouldn't exist. Natural surfaces are messy, dust smears, ice fractures, rock crumbles, edges soften over time. These didn't. They stayed crisp. Every rotation brought the same pattern back into view. Same width, same spacing, as if the surface had been divided on purpose. The first explanation was simple: layers of ice and dust, deposits from different eras, strange but possible. So they ran the models. If it were dust, the reflectivity would scatter light. If it were ice, it would flare brighter near the sun. These bands did neither. They reflected light evenly, predictably, almost conservatively, as if tuned to a range, not maximizing brightness, not minimizing it, just controlled. Someone suggested metallic content, exotic alloys formed near another star. That idea didn't last long. Metal heats fast, cools fast. But the thermal data didn't spike. The reflectivity and the heat were working together. That's when the word appeared. Not spoken aloud, just typed, then erased. Artificial. Because once you say it, You can't unsay it. The bands weren't random. They weren't scars. They weren't accidents. They were arranged. As the object rotated, the bands passed through sunlight like panels, each one behaving slightly differently. Some reflected more, some less, not wildly, just enough to matter. Like a surface engineered to manage energy, someone overlaid the reflectivity map with the thermal map. The alignment was exact. The brighter bands cooled faster. The darker bands absorbed just enough heat. Together, they balanced the object. Not perfectly, efficiently. The room grew still, because this wasn't geology. This was architecture. Still, denial held on. Denial always does. Maybe it was layered ice with impurities. Maybe cosmic radiation had altered the surface. Maybe, but every maybe required coincidence. Too many coincidences. The bands didn't drift over time, didn't erode, didn't blur. They held. Rotation after rotation, night after night, the same pattern returned, like a barcode sliding through space. Someone joked nervously that it looked like plating. No one laughed. Because plating has a purpose, and purpose implies foresight. Another researcher pointed something out quietly. The bands are evenly spaced but not symmetrical. That mattered. Nature loves symmetry. Crystals repeat. Shapes echo. This wasn't symmetric. It was optimized, as if the designer cared about performance, not beauty. The reflectivity shifts weren't dramatic enough to draw attention. They were subtle, which made them more unsettling. Because subtle design is the hardest to spot. It hides in plain sight. You don't build something subtle unless you expect it to be seen. Eventually, the debate turned heated. Dust camp versus design camp. One side argued survival bias. We notice patterns because we're looking for them. The other side asked a simple question. Why are the bands the same width every time? No one answered, because there was no good answer. As 3I/Atlas continued rotating, something else became clear. The bands lined up with the pulse, not exactly, but rhythmically. When a brighter band faced Earth, the signal strengthened. When a darker band turned away, it softened, not disappeared, softened, as if the surface itself was modulating what we received. That idea sat heavy, because modulation is communication's cousin. You don't need language to send structure. Structure alone is enough. One scientist stared at the data and said softly, "This surface isn't random. It's intentional restraint. Restraint is a human concept. It implies choice. Choice implies awareness." Again, no one spoke, because the closer they looked, the less this felt like an object, and the more it felt like a system. The public explanation stayed safe. Unusual reflectivity. Complex surface composition. Nothing false, nothing complete. Behind closed doors, people asked harder questions. If this is artificial, why hide it so well? Why not shine? Why not signal clearly? Unless it wasn't meant for us. Unless it was built to function, not announce. Infrastructure doesn't wave. It works. The reflectivity bands kept sliding across the data, patient, consistent, unimpressed by debate. And that indifference was the most frightening part, because it suggested confidence, as if the object didn't care who noticed, as if it had already done its job, long before we were here. Someone finally said what everyone was thinking. If this is design, it's old. Very old. Eroded just enough to pass as natural. Advanced just enough to survive stars. Balanced between visibility and secrecy. The perfect disguise. Nature with intention hidden inside. As the rotation continued, the bands caught sunlight one last time. Bright, dark, bright. A repeating question written in reflection. Are we seeing material or design? Are we observing erosion or engineering aged by time? The data didn't answer. It just kept turning. And as 3I/Atlas drifted farther away, one truth settled in. If something can shape how it reflects light, if it can choose how it appears, then appearance is no longer accidental. It's a decision, and decisions imply agency. The reflectivity shift faded slowly as distance grew, but the pattern never vanished. It stayed locked in the archives, waiting, like a fingerprint left on the universe. Because once you recognize design, you start seeing it everywhere. And once that door opens, there's no closing it. The object moved on, silent, stripped of sunlight, but its surface had already spoken, not in words, in structure, and structure is the hardest language to deny. As the chapter closed, one question remained. If this surface was built to control light, what else was it built to hide? And what happens when something designed to blend in no longer needs to? There is a moment in every discovery when curiosity becomes danger. Not because of what you find, but because of what you allow yourself to test. For weeks, the question had lived in whispers. Typed, then deleted. Thought, then dismissed. What if we're wrong about what this is? Not composition, not size, not trajectory, but category. What if 3I/Atlas isn't an object at all? What if it's a system? That question sat behind locked doors, because to ask it openly would cross a line. Science survives on assumptions, and one assumption has always held firm. Interstellar visitors are natural. Rocks, ice, debris, not machines. So when a small group of researchers decided to test a different idea, they didn't announce it. They didn't publish. They didn't even agree on who should know. They just ran the simulations, quietly, late at night, on personal machines, away from official models. They took the same data everyone else had, the light curve, the pulse, the thermal regulation, the reflectivity bands. But instead of asking, how would a rock behave, they asked something forbidden. How would a machine behave if it wanted to survive a star? The first results were uncomfortable, not shocking, not dramatic, just better. The curves aligned more cleanly, the thermal shifts made sense. The reflectivity bands stopped being strange. They became functional. Heat shields, radiators, energy balance zones. The pulse wasn't noise. It was timing, internal timing, a reference cycle. The model didn't need miracles. It didn't break physics. It just used physics differently, efficiently. One researcher leaned back in his chair and said nothing for a long time, because the simulation didn't prove anything. It did something worse. It explained things. And explanation is seductive. They refined the model, removed unnecessary assumptions, asked simpler questions. What if the object wasn't accelerating, but correcting? What if the surface wasn't eroded, but aged, What if the design wasn't perfect? Because it was ancient. The fits improved again. No wild intelligence, no super tech, just something built to endure, built to regulate heat, built to manage light, built to keep time. A machine, not alive, but not dead either. Something in between. Someone finally said it out loud. If this is artificial, it doesn't matter how far it came from. Everyone froze, because distance had always been the shield. Interstellar meant unreachable, unrelatable, harmless. But origin changes everything. If it was built, then someone built it. And if someone built it, then intelligence isn't rare, it's patient. The simulations didn't scream alien craft. They whispered something more disturbing: infrastructure, something placed long ago. Meant to last. Meant to pass through systems quietly, like a buoy, or a probe, or a relic still doing its job. Long after its makers disappeared, the group argued among themselves. Hard. Some said the model was dangerous, that it encouraged imagination over restraint. Others fired back. We didn't imagine this. The data led us here. That's what made it terrifying. No assumption had been added. Only one removed. The assumption that it had to be natural. Once that wall came down, everything fit. The pulse became maintenance. The heat became regulation. The reflectivity became control. And suddenly, the object wasn't mysterious. It was logical, and logic, when applied to the wrong premise, reveals truths you're not ready for. One researcher closed the simulation and refused to open it again. He said, "Even if this is right, we can't be the ones to say it, because saying it would change things. Funding, trust, public fear. Science moves slowly for a reason. Truth, sometimes, moves too fast." The group agreed on one thing: no papers, no press, no leaks. Not yet. They returned to public models. Safe language, careful phrasing. But they couldn't unsee what they'd seen. Every new observation echoed the machine model. Every update tightened the fit. The object wasn't just surviving space. It was designed for it. That realization carried a deeper weight. If this was a machine, it wasn't aimed at Earth. It didn't slow down, didn't adjust for us. Which meant we were incidental, not targets, not recipients, observers. And that hurt, because humanity wants to matter, wants to be chosen. This suggested something colder. We were just another star, another waypoint, another data point. The most unsettling question came last. If this machine was built, and it's still functioning, how many others are there? And how many have already passed, unnoticed? That thought sat heavy in the room, because the universe suddenly felt less empty and more organized, as if pathways existed we had never seen. The group disbanded quietly. No goodbyes, no celebration. Just people walking away with a secret they didn't ask for. They went back to their normal work, normal objects, normal models, but nothing felt normal anymore. Because once you allow yourself to ask, what if this is a machine, you can never fully unask it. The question lingers. It shadows every graph, every curve, every pulse, and it leads to a truth science rarely admits. Sometimes, what matters most is not how far something traveled, but why it was sent. As 3I/Atlas continued drifting away, the machine model stayed locked in a private folder, unpublished, unspoken, but correct. And correctness, when ignored, doesn't go away. It waits, just like the object itself, silent, patient, a reminder that origin is not about distance. It's about intention, and intention, once suspected, changes everything. In the next chapter, the secret escapes the lab, and the world begins to react. The leak didn't explode, it hissed. A screenshot here, a sentence there, a half-understood graph posted without context. That's how it always starts. Not with truth, but with fragments. Someone noticed an unusual thread on a forum. Someone else shared a clip from a private talk. A phrase kept repeating, "Interstellar anomaly." By morning, it was everywhere. Social media did what it always does. It amplified confusion. Some people felt awe immediately. Late-night posts about visitors, about destiny, about finally not being alone. Others laughed it off, called it fake, called it clout. Just another rock. Clickbait science. Nothing ever happens. The fracture was instant. Because people don't argue about facts anymore. They argue about meaning. News outlets scrambled to catch up. Headlines stayed careful. Unusual interstellar object observed. Scientists study mysterious visitor. No mention of pulses. No mention of regulation. Just enough mystery to attract clicks. Not enough to cause panic. But the internet doesn't wait for permission. Diagrams were misread. Data was distorted. The word artificial slipped into comment sections like a virus. Some embraced it, others rejected it violently. "How arrogant do you have to be," they said, "to think everything is about us?" That line hurt because it was right. Live streams popped up overnight. Self-proclaimed experts explained things they didn't understand. People argued in all caps. Fear mixed with excitement. Hope mixed with mockery. Human static filled the air. Noise layered on noise. Meanwhile, 3I/Atlas didn't change. The pulse didn't stutter. The light curve didn't react. The thermal regulation stayed calm, as if nothing had happened. As if an entire species could wake up screaming, and it wouldn't matter. That contrast unsettled the scientists the most. Because if this object was watching us, it gave no sign. If it was aware of us, it didn't care. No adjustment, no response. Just the same rhythm. Tick, pause, tick. Like a metronome playing to an empty room. Inside research centers, the mood shifted again. This wasn't about data anymore. It was about control. Once the public notices something, you can't put it back. Questions poured in. Emails flooded in boxes. Is it dangerous? Is it a probe? Why won't NASA say the truth? There was no single truth to give, only uncertainty. And uncertainty is gasoline. Some scientists went quiet. Others spoke too much. Every word was analyzed. Every pause clipped and shared. People searched for meaning in tone, in eye movement, in silence. But the object offered none. It remained indifferent. That indifference cut deep. Because humans are storytellers. We expect cause and effect, call and response. We wave, something waves back. This didn't. It passed through our awareness like a ghost. not hostile, not friendly, just there. A few voices tried to calm the chaos. This is normal. Science takes time. Don't jump to conclusions. They were drowned out, because the idea had already escaped. Something out there doesn't need us. Something can exist, function, endure, without ever acknowledging we exist at all. That idea terrifies people, because it makes us small. Some turn to faith, others to fear. Conspiracy theories bloomed instantly. It's hiding, it's watching. They know more than they're saying. Trust eroded fast, not because of lies, but because of silence. And silence always feels intentional. Inside one control room, a senior scientist stared at the live data feed while the world argued. The pulse continued. Perfect. Unbothered, he said quietly. It doesn't even know we noticed. That thought landed like a weight, because awareness is mutual, only if both sides care. This suggested something colder. The object wasn't ignoring us out of arrogance. It was ignoring us because we weren't relevant. That's harder to accept than hostility. Hostility means recognition. This was something else. A mirror held up to humanity, showing how loud we are, how reactive, how desperate to be seen. And in that mirror, we saw only ourselves. The sky didn't change. Stars didn't blink. The object didn't adjust its course by a fraction. As days passed, attention shifted. Some people got bored. Others doubled down. A few clung to the idea that this was proof of connection, of destiny, of meaning. Others rejected it completely, because both hope and denial are ways to avoid one thought: that we are not central, that we are not addressed, that the universe may be full of systems, moving quietly, indifferent to who notices them. The scientists felt that weight more than anyone. They had data, but no language. How do you explain indifference? How do you tell people that something extraordinary might exist and still not care? You don't. So they spoke carefully. And the gap between what was said and what was known only widened the noise. Through it all, the signal stayed calm. No flare, no response, no acknowledgement, just rhythm. Like a clock in an empty building, still ticking long after everyone has left. And that led to a final, unsettling thought. If this object was built, if it had origin and purpose, then maybe its purpose wasn't discovery. Maybe it was passage. Maybe it had already done this countless times, passed countless worlds, ignored countless awakenings, leaving behind only questions. As the noise peaked and then slowly began to fade, one thing became clear. Our reaction said everything about us. Its lack of reaction said everything about it. The static died down eventually. Trends moved on. Attention shifted, but the object remained, silent, measured, unchanged. And in that silence, a question echoed louder than any headline. If something so precise, so controlled, so ancient, can pass through our awareness without pause, what does that say about our place in the story? And if it ignored our awakening completely, was it ever meant to wake us up at all? As the pulse continued, steady and indifferent, one truth settled in. The universe doesn't announce itself. It doesn't wait for consensus. It simply moves. And sometimes We are just the static it passes through. In the next chapter, the noise fades, and patterns begin to stretch across time itself. Because when something doesn't respond to attention, you start wondering what it does respond to. Time changes everything. At least, that's what we believe. Natural systems drift, signals decay, patterns blur as weeks turn into months. That belief is comforting. It tells us that if we wait long enough, mystery will soften into explanation. So they waited. They let 3I/Atlas move farther away. Let distance stretch. Let attention fade. And then they looked again. That's when the pattern refused to disappear. Weeks of data became months. Months stacked into a timeline long enough to see something new. Not noise, not coincidence, structure. Every anomaly, every pulse, every thermal shift, every reflectivity band linked back to the same underlying rhythm, the same spacing, the same timing, the same internal logic. It was all connected, not layered randomly, but arranged. Like different instruments playing the same song at different volumes, the light curve bent in time with the pulse. The heat followed the reflectivity echoed the rotation. Nothing stood alone. That's when someone said the word no one wanted to use: memory. Because memory isn't repetition. Memory is consistency across change. And this object was changing its position, its distance, its orientation, but not its behavior. It behaved the same way it had weeks ago, months ago, as if it remembered what it was supposed to do. That idea made people uncomfortable, because memory implies persistence, not just of structure, but of purpose. A senior analyst did something simple. She stripped the timeline of labels and dates. No day 1, no week 4, just sequence. And there it was, a cycle repeating across time, not perfectly, but faithfully. Small variations, no breakdown. Like a routine followed for a very long time. Chance doesn't do that. Chance wanders. This didn't wander. It returned again and again. The realization hit quietly. This object wasn't reacting to us, or the sun, or the moment. It was following an internal schedule, one that didn't care who was watching. That's when the question shifted. Not, is it artificial? But why does it repeat itself so carefully? Repetition costs energy. Maintenance costs effort. You don't build systems that repeat forever, unless repetition matters, unless something, somewhere, is meant to notice. That thought split the room. Some said, no, not notice us, just notice in general. A beacon, a reference point, a marker in space. Others disagreed. Beacons broadcast. This whispered. Marcus, stand still. This moved. It didn't announce itself. It revealed itself slowly, only to those who kept watching. That distinction mattered. The pattern wasn't obvious at first glance. It only emerged with patience, with long-term attention, with memory, which led to an unsettling possibility. What if it was designed that way? What if the object wasn't built to be found, but to be recognized? Recognition requires time. It filters out the impatient. Only those who observe long enough, carefully enough, would see the structure. That felt intentional. as if the builders understood something about intelligence, that it reveals itself not through force, but through persistence. Someone ran a comparison. They tested how long it would take a civilization like ours, with modern telescopes, to detect the pattern. The answer was chilling. Decades ago, we wouldn't have seen it. A century ago, impossible. Only now, only with this level of precision, this level of patience, could the structure emerge. That timing felt wrong, or too right. The object wasn't shouting into the void. It was waiting for someone capable of sustained observation, waiting for a species that understood patterns, time, systems, waiting for memory. The idea unsettled everyone, because waiting implies expectation. Expectation implies audience, and audience implies intent. At this point, denial became harder to hold. The anomalies weren't independent mysteries anymore. They were expressions of the same design, seen from different angles. Heat management, light control, timing, all serving one structure, one repeating logic, a logic that didn't erode with time. That meant it wasn't fragile. It was robust, built to endure centuries, millennia, possibly longer. Someone asked a quiet question: if this thing has memory, does it know when it's being observed? No one answered, because that question had no safe direction. If yes, then we were late. If no, then we were irrelevant. Neither option felt good. As the months passed, something else became clear. The pattern didn't change, but our interpretation did. At first, it felt alien, cold, mechanical. Now it felt patient, not alive, not aware in a human way, but persistent, like a road that stays paved long after cities rise and fall, like a message carved in stone, not meant for one generation, but for many, that reframed everything. Maybe it wasn't built for us. Maybe it was built for whoever came next. A breadcrumb in the galaxy, a test, not of intelligence, but of attention. Do you watch long enough? Do you remember what you saw last month, last year, last decade? Do you connect dots across time? If you do, you see it. If you don't, it passes unnoticed. That idea haunted the research teams, because humanity is impatient. We chase novelty. We move on. And yet, this object rewarded the opposite: stillness, consistency, memory. As 3IATLAS drifted farther away, the signal weakened, not because the pattern broke, but because distance diluted it, which raised another, disturbing thought. If it had passed closer, much closer, would the pattern have been undeniable? Was this encounter accidental or intentionally distant? Just far enough to be safe, just close enough to be seen by those who knew how to look. The final synthesis report was never published. It couldn't be. It didn't conclude. It only connected. And connection without explanation is dangerous. But everyone who read it felt the same thing. This object wasn't random. It wasn't just surviving. It was consistent. Consistency across time is the signature of design. And design raises a final, haunting possibility. What if this wasn't the first time? What if other civilizations, other watchers, had seen this pattern before, watched it pass, noticed the rhythm, asked the same questions, and then disappeared, leading the object to continue its quiet loop through the galaxy? As the data window slowly closed, one thought lingered. if something is built to be noticed, but only by those who watch long enough, then noticing it changes you. It means you've crossed a threshold from observer to participant. And once that happens, you're no longer just studying the universe, you're part of the pattern. The object moved on. The pattern remained, locked in the data, etched in memory. And as scientists shut down their screens one by one, a single question followed them home. If this was built to be noticed, what happens now that we have? In the next chapter, the data ends, but the questions do not, because some patterns don't end with answers. They end with silence. And silence, after recognition, means something entirely different. The silence didn't arrive suddenly. It crept in. One night, the pulse was still there, steady, patient. The next night, it was weaker. Not broken, not distorted, just quieter. At first, no one wanted to believe it. Signals fade all the time. Distance does that. Space stretches everything thin. So they told themselves it was normal. But deep down, they knew better. Because this wasn't random fading. It was controlled. As 3IATLAS crossed the boundary of the inner system, the data began to change in subtle ways. The light curve smoothed out. The sharp edges softened. The anomalies didn't vanish violently. They resolved, like a breath slowly released. The pulse that once aligned across continents missed a beat, then another. The timing slipped, just slightly. Enough to notice. Enough to unsettle. Scientists recalibrated, adjusted for distance, corrected for noise. The math said it should still be there. But the signal didn't care. It was leaving. That realization hit harder than discovery ever did. Because discovery excites you. Silence forces reflection. The light curve began to look normal. Too normal. The strange bends straightened. The pauses dissolved into expected variation. If someone had started observing at that moment, they would see nothing special, just another object fading into the dark. And that terrified the people who had been there from the beginning. Because it meant the anomaly wasn't permanent. It was conditional. It existed only within a certain range, a certain window. As if the object behaved differently when it was here. And now that it was leaving, it no longer needed to. One researcher whispered something no one wrote down. It's shutting things off. No one argued. Because systems shut down when tasks are complete. Natural objects don't. Comets don't decide when to be interesting. Asteroids don't tidy up their data. This one did. The thermal patterns flattened. The regulation loosened, not abruptly, gracefully, like a machine reducing power draw once it's done. The reflectivity bands became harder to distinguish, still present, but no longer pronounced, as if they no longer mattered. The pulse, once the most disturbing feature of all, slipped beneath detection thresholds. Not gone, just unreachable. That was worse. Because absence could be explained. Intentional quiet could not. In control rooms and offices, the mood turned heavy. No one celebrated the return to normal. Normal felt wrong now. Normal felt like erasure. Someone pulled up older data for comparison. The difference was undeniable. This object had changed its behavior over time. Not decayed, changed. That implies phases, modes, purpose. A young scientist asked a question that hung in the air. What if this was the whole point? No one answered. Because the question had too many edges. What if the object wasn't meant to stay strange? What if the anomaly wasn't a flaw, but a phase? something that activated near stars, near observers, near systems like ours. And once that phase ended, it returned to silence. The idea was chilling, because it suggested intention without interaction, like a survey that never checks results, like a sensor that doesn't care who notices it, only that it passes through. The public never noticed the change. By the time the silence set in, attention had moved on. The object was old news, just another dot fading away. That contrast hurt. The most important moment passed quietly. No headline for the ending. No alert saying, "This is the last time you'll see it behave this way." It just stopped. And stopping felt deliberate, as if someone had closed a door. The pulse never came back, not even faintly. The light curve stayed boring, predictable, comforting. But comfort now felt hollow, because the people watching knew something had ended. A window had closed, and it might never open again. One senior scientist stared at the final clean data and said softly, "If this was a test, we don't know if we passed." That word, test, was dangerous. Tests have criteria. Tests have outcomes. And most unsettling of all, tests are designed. The object continued outward. Cold now. Quiet now. No longer doing anything strange. Just another traveler, leaving our system behind. But no one could shake the feeling that something had been completed. That whatever behavior had alarmed and fascinated them was never meant to last. It was temporary by design, like a light turned on briefly, then switched off. The question wasn't why did it go silent. The question was, why did it make noise at all? As the days passed, the silence hardened. Not the absence of data, but the absence of change. Everything stabilized. The last anomaly resolved. The last irregularity faded. And with it, so did the last excuse for hope. Because silence removes possibility. It forces conclusions. Either the object had malfunctioned, or it had finished. And nothing about its past behavior suggested malfunction. Machines fail messily. This did not. This ended clean, like a checklist completed. That idea haunted the final days of observation. People stayed late, long after they needed to, staring at screens that now showed nothing remarkable, trying to convince themselves they hadn't imagined it all. But the archives were real. The pulse was real. The patterns were real. And now, the silence was real too. Someone said something no one disagreed with. If it comes back, it won't be for us. That landed with a dull weight, because it implied finality. This wasn't a conversation. It was a crossing. And crossings don't repeat for the same observer. As 3IATLAS slipped beyond the reach of our best instruments, the last trace of anomaly vanished. No farewell. No sign. Just absence. And absence, when it follows structure, feels intentional, like being watched briefly, then dismissed. The sky returned to what it had always been. Stars, planets, darkness. But something had changed beneath that familiar view. We had seen something act, then stop acting. We had witnessed behavior, then silence. And behavior followed by silence is the clearest signal of all. It means the system didn't break. It completed. The final report used neutral language. In the end, nothing happened. No announcement. No confirmation. No final answer delivered to the world. The data was archived, carefully labeled, carefully stored, carefully buried inside servers that would outlive the headlines. 3I/Atlas kept moving, farther, fainter, until it was just another line in a database, another object that had passed through. News cycles shifted, attention drifted, a new crisis, a new story, a new distraction. That's how it always goes. Mystery survives longer than memory, but not longer than noise. Official statements stayed neutral to the end. Further study required. No evidence of artificial origin. Inconclusive. Words chosen not to lie, but not to disturb. Because some truths don't need to be hidden. They just need to be left unfinished. And so, publicly, the story ended. Quietly, but privately, something lingered. Inside labs and offices. Inside the minds of the people who had stared at the data too long. They couldn't forget what they'd seen. The curves that fit too well. The pulse that never drifted. The heat that stayed measured. The patterns that remembered themselves across time. You can archive data, but you can't archive doubt. Years from now, a graduate student will open an old file, out of curiosity, out of boredom. They'll notice something odd, a rhythm, a structure, and the cycle will begin again, because unresolved things don't disappear. They wait. The object itself was already gone by then, beyond our reach, beyond our instruments, passing into darker space, toward stars we will never touch, still ticking, still regulating, still doing whatever it was built to do. If it was built. That question never received an answer. Not because the answer didn't exist, but because no one was ready to own it. Because if 3I/Atlas was artificial, then the universe isn't just vast. It's inhabited by intention, not necessarily life, not necessarily consciousness, but design. And design changes everything. It means intelligence doesn't have to shout, doesn't have to visit, doesn't have to explain. It can leave behind systems that outlast civilizations. It can move patiently. Across millions of years without ever caring who notices. And that raises the most uncomfortable truth of all. If this was artificial, then we were not the destination. We were not the message. We were not the reason. We were observers who happened to be looking up at the right moment. That idea humbles people, and humility is something humanity struggles with. We like stories where discovery leads to contact, where mystery ends in revelation, where the universe turns and looks back at us. This story didn't do that. The universe stayed quiet, and silence when it comes after recognition feels intentional. As if something ancient passed by, saw that we were there, and decided we weren't ready. Or worse, that readiness didn't matter, that we are one of many, that countless eyes may have looked up before us, noticed the same thing, asked the same questions, and then vanished. Civilizations bloom and fade, stars burn and die, but systems built to endure just keep moving. The origin of 3I/Atlas remains unanswered. No signature, no message, no maker revealed. Only behavior, only structure, only patience. Which forces a final question, not about it, but about us. If we encountered something artificial and couldn't even agree on what it meant, what does that say about our maturity? If something ancient crossed our path and all we could do was argue, deny, and move on, were we ever meant to know more? Or was this the test, not of technology, but of perception? Could we notice something subtle? Could we watch long enough? Could we accept that meaning doesn't always include us? Because maybe the universe doesn't reveal itself all at once. Maybe it leaves traces, breadcrumbs, quiet systems drifting through the dark, waiting for minds capable of recognizing patterns without needing answers. If that's true, then discovery isn't the end. It's the beginning of responsibility. Responsibility to observe carefully, to remain patient, to accept uncertainty, to understand that not every mystery exists to be solved. Some exist to change the solver. 3I/Atlas didn't speak. It didn't slow down. It didn't acknowledge us. It simply passed through our awareness, left behind a question, and continued on its way. And maybe that was the point. Because now, whenever we look at the sky, we know something else is possible. Not fantasy, not fear. Possibility. That the universe may be filled with quiet systems, old designs, patient machines that don't care if we believe in them. They exist regardless. And one day, long after this generation is gone, another object may appear. Another anomaly, another pulse in the dark. And the question will return, were we ever meant to know? Or were we only meant to notice that we are not alone in our ability to build things that outlast us? The data sleeps now. The headlines are gone. But somewhere beyond the edge of our reach, something artificial or something that behaves like it is still moving, still counting, still following a path set long before Earth had a name. And that thought lingers, not as fear, but as a quiet shift in how we see ourselves. Because if this was artificial, then the universe isn't empty. It's patient. And maybe the most haunting truth isn't that something else is out there. It's that it passed by and never needed us to understand it at all. The sky goes on, so does the silence. And somewhere in that silence, the unanswered origin remains, waiting